Hello students, I am Sanjay Shirude, teacher in mathematics from Willingdon College, Sangli. Last time we have learned logarithmic differentiation and its examples. Today we are going to learn explicit and implicit function and examples on differentiation of explicit and implicit function by the help of PowerPoint presentation. Students, now we are going to continue our next type from our book exercise number 1.3, example number 3. Find dy by dx x root x plus y root y is equal to a root a. Now that can be written as x to the power 3 by 2 plus y to the power 3 by 2 is equal to a to the power 3 by 2. See here, x root x can be written as x into x raised to half. Now this is x raised to 1. So base are same, therefore take the sum of indices 1 plus half, and that can be written as x to the power 3 by 2. So I write here x to the power 3 by 2, and in the same way I write here y to the power 3 by 2 is equal to a to the power 3 by 2. Now we are going to differentiate both sides with respect to x. What do we get? Here we use the same formula. Which formula? Derivative of x raised to n. That can be written as n into x raised to n. What is n here? That is 3 by 2. So you write here 3 by 2 into x to the power 3 by 2 minus 1. Same thing is here. 3 by 2 into y to the power 3 by 2 minus 1 into dy by dx. Now on right hand side, a to the power 3 by 2 is a constant and its derivative is 0. So I write here derivative of a to the power 3 by 2 is 0. Now 3 by 2 into root y. 3 by 2 into root y, because 3 by 2 minus 1, that is 3 minus 2 upon 2, that is 1 by 2, that is half. So y raised to half, that is root y, into dy by dx. Now take this first term on that side, it becomes minus 3 by 2, x to the power 3 by 2 minus 1 becomes again x to the power half, and that is root x. So we get this type. And now dy by dx equal to, see here, 3 by 2 from both sides get cancelled. We get root y into dy by dx equal to minus root x, and take this root y on RHS in denominator. So we write dy by dx equal to minus root x upon root y. And now this is our final answer. Now we consider our next example. X cube plus x square y plus xy square plus y cube equal to 81. Now see here. Here this expression contains both the terms x as well as y. And so we differentiate with respect to x of this implicit function. Now we get derivative of x cube is 3x square. Now here by using product rule, first function x square into derivative of y plus y, that is the second function, into derivative of first, that is derivative of x square, that is 2x, plus again third term, that is the product of two terms, x into y square. Again we use product rule. So we write here x into derivative of y square, that is 2y into dy by dx, plus second term y square into derivative of x is 1. Now plus this third term is y cube. Its derivative is 3y square into dy by dx equals to 0. Now here I write x square plus 2xy plus 3y square into dy by dx. That means we consider this term and this term as well as this term. Now we take a dy by dx as common from such a term, like first term this is second term, and this is third term. See here, dy by dx common, we get x square here. Now here x into 2y, that is 2xy. Now here 3y square. Now dy by dx is common, then in bracket you write this, and now take these are terms, remaining terms on the right hand side. What we get? all terms become negative, so I take minus sign as a common, and in bracket I write 3x square, then 2xy, then y square. Now what do we get? Here we get x square plus a 2xy plus 3y square into dy by dx equal to minus 3x square plus 2xy plus a y square. Now we get our final answer, that is dy by dx equal to, now take this bracket on the right hand side, it becomes denominator. So this is our numerator, minus 3x square plus 2xy plus y square upon x square plus 2xy plus 3y square. And now this is our final answer. So we will continue our next example. X into e raised to y plus y into e raised to x equal to 1. This is again implicit function. We have to differentiate it with respect to x. Now see here, u into v. Here again u into v. First function into second function. First function into second function. By using product rule of derivative. Here I write the derivative of first term plus derivative of second term equal to derivative of constant, that is 0. Now derivative of first term becomes, by using product rule, first function x into derivative of e raised to y is e raised to y into dy by dx by chain rule, plus here I write second term e raised to y into derivative of first term, that is x, that is 1. Now plus derivative of second term. First term y into derivative of second term, that is e raised to x, that is e raised to x, plus here e raised to x into derivative of y, that is dy by dx. Again here we use product rule. And here I mention the product rule as d by dx of u into v, u into dv by dx plus v into du by dx, u that is the first function, v that is the second function. Now here again we consider the terms of dy by dx, and I take dy by dx as a common. So in bracket we get, what we get? X into e raised to y, here e raised to x, and now remaining terms I write as a second term in bracket e to the power y plus y into e raised to x. Right hand side remains the same, that is equal to 0. Now I take this second term on right hand side, it becomes minus. In bracket e raised to y plus y into e raised to x. Now take this on right hand side in denominator. So we get our final answer as dy by dx equal to minus e to the power y plus y into e raised to x upon e raised to x plus x into e raised to y. Now this is our final answer. When function is given this, then its derivative is this. And now to continue the next example. Cos of xy is equal to x plus y. Now here we can't separate these two terms, x into y. So it is an implicit function. So we take derivative of both sides with respect to x. Then we get d by dx of left hand side, that is cos of xy, is equal to d by dx of right hand side, that is d by dx of x plus y. Now derivative of cos of xy is minus sin of xy into derivative of xy with respect to x by using chain rule. On the right hand side we use addition rule of derivative. Derivative of first term plus second term, that is derivative of first term plus derivative of second term. Here derivative of first term, that is x, is 1, and derivative of second term is a dy by dx. Now minus a sin xy into x into dy by dx plus y into 1. What is this? This is the derivative of xy by using product rule. First function into derivative of second plus second into derivative of first. On right hand side we write 1 plus dy by dx as it is. We multiplying minus sin xy to this bracket, we get minus x into sin xy into dy by dx. Now minus plus minus y into sin xy is equal to 1 plus dy by dx. Now this can be written as minus x sin xy into dy by dx. Now take this dy by dx on left hand side, it becomes minus. Now this one as it is, and take this second term on right hand side, it becomes plus. And here I take dy by dx as a common. In bracket we get this. We take dy by dx with a negative sign. So we write here minus in bracket into dy by dx. So we write x into sin xy plus 1. Now on right hand side 1 plus y sin xy as it is. And now what is our answer now? Our final answer becomes now, after taking this term on right hand side as a denominator, so I write minus 1 plus y into sin xy upon 1 plus sin xy. This is our final answer. Now to continue our next example, x square y minus tan inverse of under root x square plus y square is equal to cot inverse of root of x square plus y square. Differentiate with respect to x. You can't separate these two terms in terms of x square and y square. Here also. So it is a type of function implicit. So we differentiate with respect to x. So what do we get? D by dx of left hand side equal to d by dx of right hand side. That means derivative of first term minus derivative of second term equal to derivative of cot inverse of under root x square plus y square as it is. Now see here. Here x square is the first term, y square is the second term, it is the first function, it is the second function. So we use the product rule, d by dx of u into v, u into derivative of v plus v into derivative of u. So here I say x square into derivative of y square, that is 2y, into dy by dx by using chain rule, plus second term y square into derivative of x square, that is 2x. Now derivative of tan inverse root, that is 1 upon 1 plus square of root. Root and square get cancelled. So I write directly here x square plus y square into derivative of root by using chain rule. Now remember this thing. Here I can show you d by dx of this tan inverse is 1 upon 1 plus root square. What is root? X square plus y square. Square of root get cancelled. And so I write directly this into derivative of under root x square plus y square by using chain rule. On the right hand side, use the same thing. See here, derivative of tan inverse x is plus and derivative of cot inverse x is minus. So here I write minus sign 1 upon 1 plus square of root, that is this, and it becomes x square plus y square into derivative of root by using chain rule. And now we are going to see our next step as x square into 2y into dy by dx. Here 2xy square, that is y square into 2x. Now what happened? This term is same as this term. This is on LHS, this is on RHS. Both are same, so we cancel out both the terms, and so we write here 0. And now our next step is, see here. Here I will show you 2 get cancelled from both sides, y cancel from both sides, x cancel from both sides. So what we get? We get x into dy by dx plus y is equal to 0. Now take this y on the right hand side, it becomes minus. Take this y on the right hand side, it becomes minus, and take this x on the right hand side, it becomes denominator. So what is our answer? Minus y upon x. dy by dx equal to minus y by x. Now to see our next example, number 6. X plus sine of x plus y is equal to y minus cos of x minus y. This is again a same type of function, implicit function. So we differentiate with respect to x. What we get? d by dx of x plus sine of x plus y equal to d by dx of y minus cos of x minus y. Now say this is u, this is v, u plus v. So derivative of first function plus derivative of second function by using addition rule. See, derivative of x is 1. Derivative of sine is cos. Angle is x plus y. So you write here x plus y. Instead of x, we consider x plus y. So multiplying it by derivative of x plus y. Derivative of x is 1, derivative of y is dy by dx. So I write directly this. And you can understand this thing. Now derivative of y is dy by dx. Derivative of cos is minus sign. So minus minus becomes plus. Sine of x minus y. And derivative of x minus y. Derivative of x is 1. And derivative of y is dy by dx. So we get this step. And now it can be written as, see here, 1 as it is. Cos x plus y into 1, that is cos x plus y. Cos x plus y into dy by dx, that is cos x plus y into dy by dx. On the right hand side, dy by dx as it is. Sin x minus y into bracket, that is sin x minus y into 1, that is sin x minus y. Sin x minus y into dy by dx with negative sign. So we write minus sin x minus y into dy by dx. Now, here, our next step is this. We take this first term from right hand side to the left side and last term also on left hand side. And take these two terms on the right hand side. We will get this step. Cos x plus y into dy by dx plus sin x minus y into dy by dx minus dy by dx is equal to sin x minus y as it is. Take both the terms on that side, they becomes minus, and we get minus cos x plus y minus 1. So our next step is this, cos x plus y as it is, then sin x minus y as it is, and here minus 1 as it is. That means here we take dy by dx as a common from these three terms, and we get this. On right hand side there is no change. So here I say that now dy by dx equal to, now take this bracket on that side, it becomes denominator. So I write dy by dx equal to sin x minus y minus cos x plus y minus 1 upon sin x minus y plus cos x plus y minus 1. Now this becomes our final answer. And now to see our next type, number 2. Show that dy by dx equal to y upon x if we are given this example where p is constant. This is from exercise 1.3 and type number 4 or example number 4. What is our example? X to the power p into y to the power 4 equal to x plus y raised to p plus 4. Here p is constant, say. Okay. Now this is given thing. Now by taking log of both sides, why we take log of both sides? Because this is a function raised to function. So we, for the sake of simplicity, we take the log of both sides. We get log of left hand side equal to log of right hand side. Now we take the derivative of both sides. D by dx of left hand side. What is our left hand side? X to the power p, that is p into x. See here, log of x to the power p into y raised to 4 can be written as, here I will show you, this can be written as log of x raised to p plus log of y raised to 4. Same thing is on the right hand side, p plus 4 into log of x plus y. By using rules of logarithm, I write this, and now this can be written as p log x. Power becomes multiple. This becomes 4 log y. See here. And now here I will show you in next step. See here. This is our next step. See, I will write this. Now p is constant and derivative of log x is 1 upon x. So p by x is here. 4 is constant, derivative of log y is 1 upon y. So 4 upon y into dy by dx by chain rule. Same thing is here. P plus 4 into, that is a constant, can be taken out, derivative of log of x plus y, that is 1 upon x plus y. So I write p plus 4 upon x plus y into derivative of x plus y by chain rule, and it is nothing but 1 plus dy by dx. So our next step is this, p upon x, here 4 upon y into dy by dx, p plus 4 upon x plus y. We multiplying this bracket by this term, p plus 4 upon x plus y into 1, that is this, and same term into dy by dx, that is this. And now we consider our next step as, see here, now I will take here this dy by dx on left hand side and this p upon x on the right hand side. Now you will see here 4 upon y minus p plus 4 upon x plus y. This becomes minus now and we take dy by dx as a common. Now on the right hand side we write p plus 4 upon x plus y as it is, and this p upon x, if you take on the right hand side, it becomes minus. And so what is our next step? See here, I take the cross product. 4 into x plus y, that is 4x plus 4y. Now y into this with negative sign, that is minus a py minus 4y upon y into x plus y. Now same thing on the right hand side. We take the cross product and we will get this. And now what we see here, here from both sides x plus y get cancelled. Now in denominator on LHS, see here, 4y get cancelled, plus minus. Now here plus a px minus px get cancelled. So what we get? See here, what is our next term? Here 4x minus py upon y into dy by dx is equal to 4x minus py upon x. Now this is our next term. And now what we write? Dy by dx equal to, see here, again here I say that 4x minus a py get cancelled from both the sides. Now take this y on left hand, from left hand side to the right hand side. What we get? Take this y on the right hand side, it becomes numerator and we get y upon x is our answer. Now this is very nice example. We take this one more example of same type here. See here, it's a common example. X to the power m into y to the power n is equal to x plus y raised to m plus n, where m and n are constants. Now it is very important example for board as well as CET. You can write the direct answer in CET exam. See here, this is given. Now by taking log of both sides we get this. Log of left hand side equal to log of right hand side. Now by taking derivative of both sides, d by dx of left hand side equal to d by dx of right hand side. Now again here I say that this term, see here, I will show you, this can be written as log of x raised to m plus log of y raised to n is equal to m plus n into log of x plus y. Students, it becomes m log x here. Now this becomes n log y. Now on right hand side there is no change. And then we take the derivative of both sides, we get this step. And now here we will continue the next step. See here. Now here we consider the derivative. Here derivative of m into log x, that is m into derivative of log x, that is m into 1 upon x here, then n into 1 upon y into dy by dx by chain rule. And now constant can be taken out, m plus n into derivative of log of x plus y. Derivative of log of x plus y is 1 upon x plus y into derivative of x plus y by chain rule, and derivative of x is 1 and derivative of y is dy by dx. Now our next step is, see here, m upon x plus n upon y into dy by dx. And now we write this m plus n into x plus m plus n upon x plus y into 1, that is this first term on right hand side, and multiplying to the next term we get this. And now here our next step is n upon y minus m plus n into x plus y. What happened here? We take the term of a dy by dx from right hand side to the left hand side and take this first term on that side. We will get this. After some calculations, simple calculations, you will write directly such steps. And now by taking cross product here as well as here, what happened? We get this. And now here I will show you, see here, n into this x plus y, that is nx plus ny. Now y into m plus n with negative sign. So we get minus my minus ny. Here in denominator you write y into x plus y. Same thing in RHS. Now here plus ny minus ny get cancelled. Then plus mx minus mx get cancelled. X plus y get cancelled. So what we get? Our next step is nx minus my upon y into dy by dx is equal to nx minus my upon x. And now you say that numerator from both sides are same, so we cancel it. And now our next step is dy by dx is equal to y upon x. Now this is our final answer. Now we will continue the next example. Sec of x to the power 5 plus y to the power 5 upon x to the power 5 minus y to the power 5 equal to a square, where a is constant. Now given that sec of bracket equal to a square, very simple. We can write this by using definition of inverse. Sec theta equal to something, so theta equal to sec inverse of something. So I write this, and now this is a constant and it denoted by k. Here I write say. This is a constant equal to say k. Now take this denominator on right hand side. What we get? X raised to 5 plus y raised to 5 is equal to k into x raised to 5 minus y raised to 5. Now k into y raised to 5, that is minus k into y raised to 5, take on left hand side, we write in this way, y to the power 5 plus k into y raised to 5. Now take this y raised to 5 on right hand side. So see here, we take the same terms on left hand side, that is y raised to 5, and we take the same terms on right hand side of x raised to 5, and we will get this. Take this x raised to 5 on right hand side, we write with negative sign, and k into x raised to 5, that is this. And now I take here y raised to 5 as a common, here x raised to 5 as a common, we get this. Now you can write in this way, y raised to 5 is equal to x to the power 5 into k minus 1 upon k plus 1. Take this 1 plus k on that side, we will get this, and we denote this by equation 1. Now d by dx of y raised to 5 by taking derivative of both sides. Now d by dx of right hand side. Now what you say here, this bracket is constant, can be taken out from derivative, and then you write this bracket into derivative of x raised to 5. See here, bracket into derivative of x raised to 5 becomes 5 into x raised to 4. On left hand side, derivative of y raised to 5 is 5 into y raised to 4 into dy by dx. Now here 5 get cancelled. So our next step is dy by dx is equal to bracket into x raised to 4 upon y raised to 4. So we get this. But in equation 1, we are given this. And from equation 1, you can find the value of this bracket as y raised to 5 upon x raised to 5. And we will put here the value of bracket as y raised to 5 upon x raised to 5. I write the reason here. And now x raised to 4 get cancelled. Y raised to 5, y raised to 4 get cancelled. So what do we get? Here we get y in numerator and x in denominator. So our answer is dy by dx equal to y upon x. Now this is our final answer. Now we will stop here. Students, we will stop here and we will continue in the next lecture. Thank you.